हाय सम। हाय रिक, कैसे हैं आप? मैं बढ़िया, आप? मैं तो बढ़िया। होप यू आर डूइंग वेल। हाँ, तो उस दिन जो बात कर रहे थे ना, 3 डायमेंशन जियोमेट्री का जो लाइन का क्वेश्चन, समझ में आया? हाँ, वो तो समझ में आ गया। तो आप कौन सा चैनल फॉलो करते हैं?
हाँ, वही SSD कैप्सूल्स फॉलो करते हैं।
SSD कैप्सूल्स। मैं भी तो SSD कैप्सूल्स ही फॉलो करता हूँ। तो चलिए आज फिर से कुछ नया कॉन्सेप्ट सीखते हैं SSD कैप्सूल्स चैनल में। वेलकम यूट्यूबर्स, कैसे हैं आप सब लोग? आशा करता हूँ आप सब लोग बहुत अच्छे होंगे। मेरे इस नए चैनल, जिसका नाम कि आप देख पा रहे होंगे SSD कैप्सूल्स, में आप लोगों का दिल से स्वागत है। तो इस चैनल में हम जो डिस्कस करेंगे, मेनली मैथमेटिक्स डिस्कस करेंगे, उसके साथ कुछ बोनस भी रहेगा, जैसे कुछ अलग सा मैथ छोड़ के कुछ अलग सा इंफॉर्मेशन कुछ मेरे पास अगर है तो मैं शेयर करूँगा, जो मुझे लगेगा कि आप लोगों को हेल्प कर सकता है। क्योंकि हमेशा अगर मैथ का फॉर्मूला, मैथ का थ्योरी, मैथ का प्रॉब्लम सॉल्व करता रहूँ तो ये मोनोटोनस लग हो जाएगा। तो इसलिए कुछ अलग सा कॉन्सेप्ट, कुछ भी हो सकता है जो लगता है मुझे इम्पॉर्टेंट है, जो शेयर करना वैल्यूएबल है, तो वो मैं शेयर करते रहूँगा। हो सकता है अलग सा उसका वीडियो बना दूँ, या मैथ का जो वीडियो मीन्स चल रहा होगा उसके बीच बीच में या आखिर में एक बोनस टाइप्स का, कैप्सूल्स टाइप्स का रहेगा। ठीक है, तो आज जो हम लोग सीख रहे हैं, जो कॉन्सेप्ट हम देखेंगे 3 डायमेंशनल जियोमेट्री का, क्लास 12 NCERT फॉलो करेंगे CBSE बोर्ड का। तो क्लास 11 में हम ऑलरेडी 3 डायमेंशनल जियोमेट्री का कुछ कॉन्सेप्ट सीख के आए हैं। वहाँ पे मेनली कार्टेशियन कोऑर्डिनेट हमें सीखने को मिला था, जहाँ पे वी हैव कंसिडर्ड x axis, y axis, z axis as the Cartesian coordinate system in 3 dimensional space. So here in the blackboard, as you have watching, I will draw one Cartesian coordinate axis. So I have taken this as x-axis, this is y-axis, this is z-axis, this is origin. So class 11 में we have studied about directed line segment, right? Also we have learned about the concept of direction angles. So if a line passes through a origin in the Cartesian coordinate system, and if it makes angles alpha, beta and gamma with the respective x-axis, y-axis and z-axis, then this alpha, beta, gamma are called direction angles of this directed line. So we are taking a line which will passes through this origin. Say this is P Q. Let this angle, let this line segment makes angles alpha, with x-axis, beta with y-axis and gamma with z-axis. So here we write down, if a line segment not a line segment, as we have studied vector chapter, we will call it as directed line segment. If a directed line segment which passes through origin and makes angles alpha, beta, gamma with the Cartesian coordinates OX, OY, OZ respectively, then we call alpha, beta, gamma as reaction angles of the line segment, directed line segment. Okay. So we know that in space, any directed line segment has two directions. So if we reverse the direction of this directed line segment, then the direction angles will be changed to their supplements. So we write that if we change the direction, of the directed line segment, then new direction cosines will be pi minus alpha, pi minus beta, pi minus gamma. So the direction angles are changed to their supplements, right? So accordingly, what will be the direction cosines? What is direction cosine? First we will study what is direction cosine. If we take the cosine of these direction angles, then what we will get is called direction cosines of the line segment. So cos alpha, cos beta, cos gamma, that is cosines of the direction angles. Cosines of the direction angles are called direction cosines of directed line segment. But as we have already seen that if we reverse the direction of the line segment, then the direction angles are changed to pi minus alpha, pi minus beta, pi minus gamma. I have done some mistake here. Here, if we change the direction of the directed line segment, then new direction cosines, not direction cosines. Not direction cosines, it will be direction angles, right? New direction angles will be pi minus alpha, pi minus beta, pi minus gamma. So we have another set of direction cosines for that same line segment taken in opposite direction which are cos pi minus alpha, cos pi minus beta, and cos pi minus gamma, which are nothing but minus cos alpha minus cos beta minus cos beta minus cos gamma, right? So how this signs changes we will discuss in the next slide. Here we apply the all sin tan cos rule of trigonometry, right? I will show you. Here first quadrant, second quadrant, this is x o x y o y dash, first quadrant. Similarly, this is second quadrant, third quadrant, and this is fourth quadrant. And we know that this is all sin, tan, cos. This is the formula, all sin, tan, cos. In details, we will discuss it in trigonometry chapter, which belongs to in class 11. Okay. So in this second quadrant, sine and cosec has positive sign, except all these trigonometric ratios will take negative signs. So we consider cos pi minus alpha equal to cos 2 into 90 degree minus alpha. So it will become, as here it is 2, so it is remains cos. So 2 into 90 degree means 190 degree, 290 degree. Minus alpha means reducing, so this reducing the angle, so this cos minus pi minus alpha remains in the second quadrant. Okay, so as it remains in the second quadrant, and it will take the negative sign. Thus in the previous page we have written that the new direction cosines are minus cos alpha, minus cos beta, minus cos gamma. Okay, so we have seen that, so we have seen any directed line segment has two sets of direction cosines, right? So how to find a unique set of direction cosines? To find a unique set of direction cosines, we have to fix the direction of the directed line segment. As in the vector chapter we have studied, for any directed line segment we have two directions. But for two directions we get two set of direction ratio cosines. So to get particular unique set of direction cosines, we have to fix the direction of the directed line segment. So note, to avail a unique set of direction cosines of a line, we have to consider a fixed direction of the line segment. Okay. So another case arises when a line is not passing through the origin. In that case, how to find the direction cosines of that line? So in the next slide, we will discuss that. How to find the direction cosines of a line which is not passing through origin. Actually, when the line passes through the origin, then it is in the three-dimensional geometry, it is easy to find the direction cosines because we get the direction angles which the line makes with the x-axis, y-axis, z-axis. Then take the cosines of these angles, then we simply get the direction cosines, right? But the problem arises when the given line does not pass through the origin. In that case, we will draw a line parallel to the given line and take this parallel line through the origin. See the diagram. See, this is x-axis, this is y-axis, this is z-axis. See, there is the line which is not passing through the origin, right? Name this line as A, B. So how to find the direction cosine of that particular line? Take another line. Okay, take another line which will pass through the origin and parallel to the line segment AB. Okay, so we know that in vector chapter, if two lines are parallel, then they are said to be collinear. So then this AB vector and PQ vector are collinear vectors. Okay. Beside that, we know that this PQ line, for this PQ line, we can easily get the angles which it makes with the coordinate axis, that is x-axis, y-axis and z-axis. And two parallel lines have same set of, we will just prove that two parallel lines have same set of direction cosines. Because two parallel lines will make same angles with the x-axis and y-axis and z-axis. So if PQ let us consider AB vector which is not passing through origin. Now draw a parallel line to AB, parallel line PQ to AB, which is passing through origin. So these two lines have same set of direction cosines as two parallel lines have same set of direction cosines, we are done, because we can get the direction cosines already, hence proved. Now in the next slide we will learn the concept of direction ratios. Any number, what is direction ratio? What is direction ratio? Any number which is proportional to the direction cosines are called direction ratios of the line segment. Some authors also call this direction ratio as direction numbers. So if a directed line segment AB vector has direction cosines as L, M, N, then for any lambda belongs to R and lambda not equal to 0, that is lambda is a non-zero scalar. Okay, for any lambda, lambda L, lambda M, lambda N are direction ratio of line AB vector. We can denote it by A, lambda L, B, lambda N, C, lambda N. Okay, so this is the concept of direction ratios. If direction ratios are given, how to obtain the direction cosines? We will find this trick in the next slide. The problem is how to find direction cosines of a line when direction ratios for that line are given. Will you solve it in today's video? No. Take this as home assignment. If problem happens, we will solve it in the next video. Thank you for watching.